Today we're going to be looking at Unit 3, Lesson 2, Angle Bisectors. So for our vocabulary today we have in-center. So we have some theorems to start off with. Our first theorem is Theorem 1.4, Angle Bisector Theorem. So if a point is on the bisector of an angle, then it is equal distance from the sides of the angle. So we have F right here. It's at a point on the bisector of the angle, so it is equal distance from D and from E. The converse of the angle bisector theorem states that if a point in the interior of the angle is equal distance from the sides of the angle, then it is on the bisector of the angle. So we see point F right here is equal distance from both of the sides, so it's going to be on the bisector of the angle. So let's take a look at the first example. So we want to use the angle bisector theorem to find QT. So QT is right here. So QT. So I notice that RT is the angle bisector of angle QRS. Since this is the angle bisector of QRS, then we know that QT and we know that ST are equal to each other. So QT equals ST, and this is by theorem. So let's plug in what we have. So that gives us 4x plus 8 equals 9x minus 7. So I want to solve this out. So I'm going to start off with getting x on one side. So minus 4x minus 4x. That gives me 8 equals 5x minus 7 plus 7 plus 7. That gives me 15 equals 5x. Divide by 5. So x equals 3. So to find QT, I'm going to plug this back in. So 4 times 3 plus 8. So 4 times 3 is 12 plus 8. So that's going to tell me that QT equals 20. Let's take a look at example 2. So example 2, we're going to use the converse of the angle bisector theorem. So we want to find the measure of angle ZYW. So this angle right here. So because WX is perpendicular to YX, and because WX is perpendicular to YZ, and we also notice that WX equals WZ. They're both equal to 5. WX equals WZ. Then W is equal distance from the sides. So this tells us that the converse of the angle bisector theorem, that YW bisects angle XYZ. So because it bisects angle XYZ, then angle ZYW is congruent to angle XYW. So the measure of angle ZYW equals the measure of angle XYW. And we have XYW right here. We know that's 38. So this equals 38, which means the measure of angle ZYW is 38 degrees. I'll put the little degrees there. So we have another theorem. So we had theorem 1.6 in center theorem. The angle bisectors of a triangle intersect at a point called the incenter that is equal distance from the sides of the triangle. So we have point P is the incenter of this triangle, and it is equal distance from the sides of the triangle. So we're going to use the incenter theorem. So P is the incenter. So right here, P is the incenter of triangle X, Y, Z, so triangle X, Y, Z. We want to find the measure of LZP. LZP. So this measure right here, we want to find the measure of this. So again, P is the incenter of triangle XYZ. So XP right here bisects this angle. Because it bisects this angle, then we know that these two angles are going to have the same measure. Or this big angle right here is twice what this is. So the measure of angle LXK equals 2 times the measure of angle PXK. So that's going to be 2 times 24.6. So that's going to give me 49.2 degrees. Also, we have over here angle KYJ. KYJ. This one is bisected by YP. So the measure of angle KYJ equals 2 times the measure of angle PYJ. PYJ. And we know the measure of angle PYJ is 25.1. So this is going to give me 2 times 25.1, which is 50.2. So now I have this angle right here is 49.2. I have this angle right here is 50.2. I need to find this last angle over here. Well, to find this last angle over here, I'm going to use this whole triangle X, Y, Z. And we're going to use triangle X, Y, Z equals 180 degrees. The measure of all the angles inside the triangle add to 180 degrees. So what does that break down to? The measure of angle LXK plus the measure of angle KYJ plus this last one right here, the measure of angle LZJ. So that's our only unknown one, equals 180 degrees. And this is known as triangle sum theorem. This is from a previous course. So plug in our information. So this is 49.2 plus 50.2 plus, this is our only one we don't know, measure of angle LZJ equals 180 degrees. So add these two together. So 40.2 plus 50.2 gives me 99.4 plus measure of angle LZJ equals 180 degrees. Subtract 99.4 from both sides, minus 99.4. That gives me the measure of angle LZJ equals 80.6 degrees. So we have that this whole thing right here is 80.6, but we want LZP. We only want part of it. We don't want the whole thing. Well, we know ZP bisects this whole big angle right here. So if it bisects this whole big angle, then the measure of angle LZJ equals, we're going to take half of that. Oh, sorry, not LZJ, LZP. LZP, which is the one we want to solve for, is equal to half that big one, LZJ. LZJ. Measure of angle LZJ, which we solve for up here. So the measure of angle LZP equals 1/2 times 80.6, which is 40.3. So the measure, I'll put it over here off to the side, of angle LZP equals 40.3 degrees. So the big thing with these is make sure you're keeping track of each of your steps. It can get a little confusing with all the work you're doing, but keep your work organized like I did. I did my first two angles over here. After I did my first two angles, I used that information in the triangle sum theorem to come up with my third angle, and then I just found the value of half my third angle. So we're going to hold off on the last one using angle bisector. We're going to put all these together at a later date, and we're going to use some compasses and protractors to work on this. But for right now, we're going to hold off on example 4. So write a quick little summary on what you learned today and the theorems in your own words, and use these notes to help you answer the practice problems for the section.